Antarctica. Over hundreds of thousands of years, planet Earth slips into and out of deep ice ages. These changes in climate are cyclical, predictable even. They're caused by slight variations in Earth's orbit around the Sun. Scientists find evidence for these changes in ice cores from Antarctica and Greenland. Occasionally, these ancient records have alarmed researchers. It seems that sometimes the climate changes abruptly in a matter of decades. Variations in Earth's orbit can't explain this behaviour. In 2001, the UK's Natural Environment Research Council announced the £20 million Rapid Climate Change Programme, an audacious plan to investigate the causes of abrupt climate change and the risk of it happening again. Ocean circulations distribute heat around the planet and influence the climate system. The circulations depend on temperature and salinity and are sensitive to changes in these parameters. Climate models predict that rising greenhouse gas levels may cause the circulation to slow down. In the past, this change of state has sometimes happened abruptly, bringing rapid cooling to parts of the globe. The North Atlantic is particularly sensitive to changes in temperature and salinity. The circulation here is complex and known as the Atlantic Meridional Overturning Circulation. The circulation brings warm water towards northwestern Europe. As it does, it releases heat to the atmosphere. The heat transferred is equivalent to 1 million power stations and helps ensure Europe's temperate climate. As warm surface waters move north and cool, cold water returns south at depth, completing the circulation. Mount Teide, on the island of Tenerife, the highest point in the Atlantic Ocean. Scientists are on the island for the start of the Rapid Climate Change Expedition. They'll spend the next month deploying an array of 22 scientific moorings across the Atlantic between Africa and the tip of Miami. The instruments will measure the overturning circulation on a daily basis. Until this expedition, scientists had little idea how this circulation varied year on year, let alone every day. They sail along latitude 26.5 degrees north. This is where the ocean transports most heat northwards. Preparations are underway to deploy a mooring. Instruments and buoys are attached to cables that stream out behind the ship. This takes many hours.
I'll give you a shout when the first buoys are over.
Finally, they release the anchor. The equipment is dragged up to 5 kilometers down to the sea floor. The instruments will spend a year in unforgiving conditions. The team work night and day deploying instruments. If successful, the moorings could be the basis of a permanent monitoring system to detect any major changes in the circulation. ship, the instruments find anchorage on Africa's continental slope. The slopes give way to the abyssal plain. 3,000 kilometers ahead lies a vast mountain range, deep beneath the surface, the Mid-Atlantic Ridge. The team deploy instruments on either side. Another 2,000 kilometers and the scientists reach the continental shelf of the United States. After deploying the array, the researchers return once more across the Atlantic. This time they stop every 50 kilometers and lower instruments to the seabed 5 kilometers below. This takes many hours. The instruments sample the water at different depths. Unlike the array deployed earlier, which will provide continuous daily measurements of the circulation, these instruments are hauled back to the surface once they've captured the various water samples. These samples provide a valuable reference point for the new array. This is only the 5th such transatlantic snapshot taken since 1957. In 2005, the results from this snapshot led to headlines around the world. It seemed that the circulation had changed markedly since previous snapshots were taken. More water was recirculating back south than before, and so less warm water was reaching the Arctic, and less cold deep water was returning south. Could the change be simply natural variability, or are our greenhouse gases to blame? Clues lie in the past. 8,200 years ago, something dramatic and sudden happened to the climate. In a matter of decades, temperatures plummeted. But for how long, and why? Researchers have found that as the last ice age receded, the giant Scandinavian and North American ice sheets melted. A huge lake, dammed by the ice, burst free, pouring large volumes of fresh water into the North Atlantic. The rush of fresh water disrupted the flow of the overturning circulation, causing temperatures over Greenland to drop 6 degrees Celsius. The freeze lasted around 150 years. The Arctic is one of the fastest warming regions on the planet. Could melting ice affect the circulation today? After a year of constant operation, the scientists retrieve the instruments. This is a tense time. Will the instruments resurface as instructed? Or has a year under immense pressure proved too much?
Yeah, that should be on the surface now.
Yeah, hope you don't got our eyes peeled up yet.
It sometimes takes a whole day to locate and retrieve a mooring.
Buoy about 50 metres starboard side towards the stern.
Scientists waste no time checking each instrument and recovering the valuable data. It's a success. Most instruments work perfectly. The team have now pieced together the first year's data. On the 17th of August 2007, the Rapid Climate Change Programme announced the first continuous daily measurements of the strength of the overturning circulation in 2 landmark papers in the American journal Science. It seems the circulation varies considerably from day to day, much more than expected. The snapshot taken at the start of the programme, showing a dramatic slowdown, looks likely to be within the boundaries of natural variability. The accuracy of the system means large, abrupt changes should be readily observed. The success of the pilot scheme has led to a further commitment from the Natural Environment Research Council to fund the system up until the year 2014, a decade of uninterrupted measurements. The Rapid Climate Change Programme is an historic achievement. Policymakers and researchers are already using the results, and it has inspired educators and artists, writers and filmmakers. The next phase is called Rapid Watch and paves the way for a permanent monitoring system for the vast Atlantic Ocean.